Now at this moment, it's time to learn about the general purpose register in RISC-V architecture. As you know, there are two types of register in RISC-V architecture. The first one is general purpose register, and the second one is control status register. The general purpose register, it could be used as the instruction input or output. In other words, the general purpose register can be used as the destination register or the source register. We have the two ways to specify the register, general purpose register in the RISC-V architecture. The first one is the architecture name, and the next one is ABI name. Take for example, X1 is architecture name of the register, and as for RA register is the ABI name. The architecture name of the register is based on the RISC-V design and hardware level, and as for ABI names, it is based on the calling convention, and there is involved the fact that how the general purpose register can be used at the software level. Let's look at the X0 register first. Register X0 is 0 register, and this register is special. Each value is always 0. You cannot change it. When you read the X0 register, you always get 0. It is useful when you need the value 0 in any of assembly instruction. And other registers are used for different purpose. Some registers are used to pass their function argument, and some of the registers are used to store the temporary value. So let's dive into more about how this general purpose register can be used. Now let's understand the RA and the SP register. These registers are very important because they are used during the function call. The RA register is also called X1 register. Then RA means the return address. When a function is called, RISC-V core saves the address of the next instruction into the RA. The address could be call return address. And this is one of the important operation when the function call is made. As for SP register, this is the stack pointer register. It is also called X2 register. It points to the top of the stack in the memory. The stack is used to store the local data, save the register, and return addresses. When the function starts, it usually moves the SP, stack pointer register, to make the space on the stack area. So when the function that completes its task, it restores the SP to its old value. This keeps the stack clean and the correct. And another important register is the A0 to A7 register. As you know that the function has the 2 or 4 null parameter. Those kind of parameter can be passed using the A0 to A7 register. Let's suppose that the particular function has the 2 parameter. As for this function, the A0 register stores the first argument, and the A1 register will store the second argument. Every time before the function call is made, using JAL instruction, you're going to see the instruction where the A0 or A1 register can be modified using MV instruction or add assembly instruction. After function complete its mission or task, it usually returns its value. That return value can be stored using the A0 register. So when you perform debugging, you usually take a look at the value of the argument. So these registers are important when you debug the specific function or particular routine. Now that you got to know about how the general purpose register is organized, the RISC-V instruction read the data from the general purpose register and write result back to the general purpose register. If you understand this register well, it is much easier to understand RISC-V assembly instruction. In the next lecture, we will practice debugging the general purpose register using trace32 debugging in program.